Okay. So, question 3. What requirements must be checked when conducting a hypothesis test comparing two means with independent samples? Mark all that apply.
So it's the, what happened to my stinking quiz? Here we go. Okay, I have that it is just the first two, right? A simple random sample was drawn and X bar is normally distributed.
Yeah,
anything to do with the mean, right?
Yeah.
Okay. And then number 4, a t-score is the test. I can't say that word, whatever that is. The t-statistic is a t-score, right?
Yeah, the test statistic.
Right.
I'm pretty sure that's what we went over yesterday.
Yeah.
Sorry, so the first one was a simple random sample was drawn from each population?
And X bar is normally distributed, so both of them.
Okay, that makes sense.
And then question 4, it's t-score.
Yes. Okay, very good. Two samples are independent if knowing which subjects will be in group 1 tells you nothing about which subjects will be in group 2.
Right.
Question 6, what are the degrees of freedom?
So, sorry, for 5, it's B, the second one?
Yeah.
Okay, just making sure because they both sounded the same.
Oh.
So typically aren't the degrees of freedom whatever the sample is minus 1?
Well, but on this one you have to put both. You have to do a 2 sample t-test.
Mm-hmm.
And so you have both of the data there. So then isn't the degrees of freedom, isn't it what's written here is 37.996?
0.996, but then that would be like 38, wouldn't it? Or
I don't know, because it always says to round to the 3 decimal places.
Weird. Well, less. Oh, did you already put in the?
I put it in, yeah.
Okay. Well, then that's probably what it is. But from what I understand is that the degrees of freedom are always like the sample size minus 1.
Wait, which one are we on?
We're on number 6.
Oh, okay. I just didn't know which ones we were talking about.
But
right, I thought the degrees of freedom was sample size minus 6. So why would it say 37?
Yeah, I have no idea.
Put it in, because I mean, I put it in before we started, but put it in and see if you have something different, because sometimes I screw up.
I'll do that.
Amazing.
We're doing the 2 sample t-test, right?
Yeah.
Okay, just making sure. Dentist office bills. I haven't been able to put that in yet. So, what is the sample size then?
The sample size is 20. Oh, wait a minute here.
Let me look. Are we looking at the Excel spreadsheet?
Yeah, it's 20. The sample size is 20.
Are we going off of how many numbers there are? Because mine, I have 21.
No, it's 20 because you have the whatchamacallit, title.
The title.
Oh, okay. Yeah, okay. Good call, good call. Wouldn't have caught that.
Oh, it's cool, it's cool. So Idaho Falls Dentist Office and Rexburg Dentist Office.
So the N, it says N, that's the sample size is 20.
Mm-hmm.
But then how come down here the degrees of freedom is 37.996?
I don't know. So my guess is degrees of freedom would be 19, personally.
Okay.
So what did you get for the degrees of freedom?
19.
And we're inputting this on the other whatchamacallit.
Right.
Oh, and you have to remember that the confidence level is 0.90. Did you change that?
Oh, I didn't.
And
Point
that,
0.90, not 0.95, right?
yeah.
We're doing this on the inference procedures, aren't we?
Yeah. And then the null is equal to, and then the alternative is that the first mean is less than the second mean.
Oh, so the type of test is we're going to do less than?
Yeah, I think so. Do we need to put in the mean and all that stuff, or is it already in there?
No, it's already in there.
Okay. So no, it doesn't really change the degrees of freedom or anything like that.
No, it didn't.
So, just wondering here, when it's taking the degrees of freedom, I think the reason it has 38 is because it's adding all the sample size, not just each individual sample.
Oh, that would make sense.
So let's go ahead and put 38 then, if that's the case.
For the degree of freedom?
I think that's what it would be.
So you think we round up or not?
I think we should round up. So 38.
Okay.
Yeah. What is the sample standard deviation for Rexburg? It says here 206.637.
Oh, would that be rounded to 206.37?
206.637.
Yeah, because it says to round to 3 decimal places, so don't we put the whole thing in there?
206.367.
Yeah.
637.
Did you round the 7 up or?
No, that's just all it gave me.
Oh, okay. Then then you're okay. Oh, now I see it on mine. Okay, I inputted the wrong thing. I need to change the confidence level.
The test statistic is that. Did you guys get negative 0.3434?
Mm-hmm.
Okay.
Yep.
And then the p-value was 0.333.
Yep.
Okay, just a second. I'm catching up to you. So it was the t-value was what? Negative 0.434.
434.
I had a bigger screen. Okay, 434.
Yeah, and then the p-value is 0.333.
Okay.
Which means that we failed to reject the null hypothesis.
Yep.
Suppose that you had used the alternative hypothesis that it is not equal to. Let's go ahead and change that and see what changes. Oh, that means the p-value is bigger. It actually doubled the p-value. What the heck?
Yeah, it did. That's weird.
So it says we have insufficient evidence that the mean dentist bills between the two cities are different.
Oh, wow.
Oh, now it looks like we need the other.
Okay, so are we on 11?
12.
We're on 11, yeah.
Oh, we are.
11 was number 2.
Okay.
Oh, it's B. The insufficient evidence?
Yeah.
Oh, good thing I put the first one because, good thing we, yeah.
Is Andrea there? I don't hear her.
She is.
Yes, I'm in the car. It's just loud. I don't want to like ruin the
Gotcha.
noise.
Where are you headed?
Back to school in Rexburg. We've been in Utah. We had some really terrible car issues, so we had to buy a new car. It's just been a disaster. So.
Are you serious?
Yeah.
Wait, what kind of car do you have?
We bought a Honda hybrid.
What kind?
Honda Civic. It's a hybrid.
Wait, that's a really good car. What are you talking about?
Yeah, no, it's a great car. It's just been kind of crazy, so I'm catching up.
That's ridiculous. I'm sorry.
Yeah, it's okay.
Weird. I'm gonna say because that's the kind of car that I want to get is a Honda Civic or Honda Accord.
Yeah, they're great cars. Really good cars. Great gas mileage.
You know what happened? Like, did the guy tell you what happened to the car?
Oh, we had a van and it's called catalytic converters. They went out. It is gonna cost like $1,600, and we're just like, might as well just get a new car. It's not worth it It's old
Oh,
van.
this must have
So
been a pretty old Honda Civic then.
yeah, so we bought a Honda Civic. Yeah, so it's good. It's good. It's worked out.
No, that's good then. Yeah, and you probably missed the storm then, which is all right.
It's okay. I'm catching up.
All right. Did you guys put in the new?
I'm working on that right now here.
Okay. It seems to me that there's a less of a sample size than before, or rather, the students from Utah. I can't even tell what that's. Oh, so
Yeah,
there's less students from Colorado than there are students from Utah. So the degrees of freedom would be 16 instead of 18. It says, what is the appropriate alternative hypothesis? You suspect that freshmen from Utah cooked dinner for themselves a different number of times than freshmen from Colorado. So the appropriate alternative hypothesis is that mu1 is not equal to mu2.
So the second one.
Yes, and I just really wanted to say mu2, so.
Let's see here.
What is the test statistic? I have 0.85.
Yeah, that's what I got as well.
Or 0.845, I guess technically.
Yeah, okay, I got that same thing.
All right, 845, yeah. I guess 'cause we have to do 3 decimal places.
Yeah, what is the p-value? I have 0.410. But we could technically change that to 0.411 because the next one is a 7.
Yeah, let's round it up. Rather be safe than sorry.
And then fail to reject the null hypothesis on 15.
Yeah.
Okay. Determine a 95% confident. Oh, did we not change that back to 0.95?
Well, we have a different
The level of significance is 0.05, which means our confidence level would be 0.95.
For the freshman dinner.
So it doesn't change the t value, but it changes the. No, it doesn't change anything.
It didn't change the test statistic or the p-value?
No.
Yeah, it didn't change on mine. They just changed it.
Determine the margin of error for the 95% confidence interval. How would you guys determine that? Because I tried before and I messed that one up. That one I got wrong.
Isn't it mu1 minus mu2?
No, let me look. I just did that last night. Let me see what I wrote down.
I can look at my notes as well. Margin of error. I need to get a notebook for this class. I just have a copy paper that I write on.
All right, where did I learn this at? So the margin of error is something is plus or minus. Shoot, she didn't write it down.
Is it Z star times sigma over n? Or no? No, I don't.
Yes, Allie, that's right. I did this last night.
Okay.
Yeah.
So to find the margin of error, we do Z star, which we would need to put in the applet, I think. Yeah, so we need the applet. I don't know if okay.
I have written down that the margin of error is the end point of the confidence level divided by, no, I don't know what this says. I don't know.
Okay, 1 second. I'm pretty sure it's the.
Do you have it D bar plus T times standard deviation divided by the square root of n?
That would make sense.
Yeah, so it's Z star times sigma over divided by the square root of n. That's the formula to find it.
That's the original formula. Is there a new one to find? this?
I don't think so.
Either way, we have to apply that to just one of the samples. So how do we do that for both samples?
I have no idea. I can't remember.
Do you think that we find the margin of error for both of them and then subtract them both, or?
Well, let me look at the question.
Okay, let me see here. I think I saw this in the textbook. Let me look and see here.
So the first thing that it says, information, determine a 95% confidence interval for mu1 minus mu2. An estimate and, oh, I think they messed that up. So, and estimate for the difference between mu1 and mu2. Input your answers below. So when it says determine the margin of error for this 95% confidence interval, I think what it's saying is that it wants the difference between the margin of error between the two.
Oh, so then you subtract 5.1, you subtract negative 2.214 subtracted by 5.147?
No, yeah.
That's the lower and upper bounds. I'm talking about the standard error, the means.
Oh, okay.
I think that's what we do. Or what we could possibly do is subtract the means 16.667 minus 15.2. And then use that as our D bar or whatever that is, or whatever it was for the Z-score. Does that make sense?
Yes, yes.
But yeah, so either we subtract the standard error of the means between the two, or we do the formula for the, I think it'd be,
right.
What is this, 1.447? That's not right? 1.467?
For the margin of error, or to input that in the formula?
Yeah, let's go ahead and input that into the formula. But I don't know if it'd be Z-score. I think it'd be the D bar minus whatever it was, and then the formula below. Do you know which one I'm talking about?
No, I'm not.
It was in the whatchamacallit?
Oh, I had this. The margin of error is D bar minus the end point of the confidence interval.
Yes. What was the formula?
I just have D bar minus the end point of the confidence interval.
What's the end point?
Or the other way to look at it, I wrote down, is half the width of the confidence level divided by 2.
Oh, wait. So you take like the confidence, like, so 5.147 plus 2.214, and then divide that by 2 is what you're saying?
I think, or is it adding or subtracting?
Well, so we want the length of the confidence interval rather than, we don't really care that the 2.214 is negative. Does that make sense?
Right. You're right. Okay.
So what would that be? 7.361? Does somebody have that?
4 point.
But why would we add and not subtract?
Oh, because we want the length rather than the, like, does that make sense?
So tell me what you got again. Let me see if I got the same thing.
So get rid of the negative sign because we don't really care about that. We just want the length of the entire thing. I got 7.361.
Right, but then that's going to be higher than the highest part of the confidence interval.
Right, but then we're going to divide that by 2, right?
Oh, okay.
Does that make sense?
Yeah.
So what's that?
So tell me the original number again.
I think somebody else should do it on a calculator. I was doing it in my head.
I have it as 3.680. Well, except the next one is 5, so 3.681.
Okay.
3.6.
Which would make sense.
Yeah, that does make sense.
Let's go ahead and put that down. I'm going to go ahead, because the next question was input the lower bound and input the upper bound. I'm going to go ahead and submit it really fast and see what I got.
And see if we got it right. Okay.
And then I'll let you guys know.
Well, don't you want to do the last two questions?
Oh, I already did those. It's the negative 2.214 and then the 5.147.
Okay, wait. So you need to tell me 17. Negative what?
Negative 2.214.
And then 18 is
5.147.
Yep.
And for 16, we put 3.681, and we're seeing if that one's right, correct?
Yeah.
Yes, 1 second. So I missed question number 6.
Okay.
I missed question 13. And question 17 and 18 are wrong, but 16 was right.
That's good.
Okay.
It's rather strange, I know, but still.
But we got everything else, but we missed 6?
Yes.
Which was the degrees of freedom.
Yeah. So we might as well.
I wonder if we're supposed to actually not round up. I wonder if we're supposed to actually do 37.996.
Let's go ahead and put that in. I'm going to go ahead and restart the quiz really fast so that way I can take it again.
Because it says right there, round to 3 decimal places.
Uh-huh. So 17 and 18 are wrong then.
No, 17 and 18 should be right.
They should be, but they're wrong.
Oh, really?
Mm-hmm.
Yeah. It's really weird.
Then what did we do wrong?
And then you said you got 13 wrong?
So I got 6 wrong, 13 wrong, and 17 and 18.
Okay.
So something's not right.
So we need to redo 13 and 17 and 18.
What did you get for 12?
Me?
Yeah.
It was the second one.
Okay, that's right. Okay.
So then we need to just find the test statistic for 13.
So what was 6 again? We're going to put 37.
We're going to put 37.996.
Okay. Go ahead and see if that's right. And 7 is right.
But 13, so this would have been using the freshman thing again.
Mm-hmm.
Oh, you know why? Look at this. Look at the information for number 12. It says, let mu1 represent the mean number of times a month that a student from Colorado cooks dinner, and let mu2 represent this mean for Utah students. So don't we have ours
mixed?
Yes, I believe so.
That's a little tricky.
Students from Utah, right?
Yeah, so Utah should really be in the second column.
Great. Should that change anything?
I don't know.
That's weird. Okay, well, let's go ahead and fix that really fast.
We just have to move them around, right?
13. Wait, we didn't get the answer for 13 yet, did we?
No.
Okay.
Can someone tell me what you guys put for 7? Because I didn't get that for some reason.
For 7, we got 206.637.
No, 367. Isn't it?
206.367?
I don't know. Niall, what did you get? I have 206.637 for number 7.
Sorry, my thing is being really weird. I'm trying to fix the data and it's being stupid. What were you saying?
What did you get for 7?
7? 7 was right. 206.637.
So I wrote it wrong. Sorry.
So what was it? I'm sorry.
206.637.
637. Okay.
Yeah.
All right, so now I have to take this out.
Oh, the stars are closer.
Okay, so now I'm looking. Did it change our T-score?
Why is this being so weird? Like not recognizing anything now. Oh, this is.
What did we put for 13 before? I didn't write it down.
What did we put for 13 before?
Yeah, that you missed.
0.845.
It was what?
0.845.
So when we switch the data, it's negative 0.845.
So maybe
that makes a difference?
Do you think?
Could.
Oh, did you get negative when you switched the data or whatever?
When I switch the data, then the T-score is now negative 0.845.
Well, then that's probably it, to be honest. Let's go ahead and put that in. Negative 0.845.
Okay. And then 14, then the p-value would be 0.412.
One sec.
See if you get that one.
681. So if we switch the data, then wouldn't it be negative 5.147 and then 2.214?
Yeah, for the 17 and 18. I was doing 14.
Wait,
sorry.
Was 14 the same?
14 we didn't get wrong.
So was the p-value 0.412?
411.
411?
Yeah, 0.411.
But what did you get for 17 and 18?
Huh. Okay.
Niall, what did you put for 17 and 18?
Oh, one sec.
Okay.
So then I think the 17, 18 are just switched.
Yeah, so 17 and 18, like I said, was negative 5.147 and 2.214.
Negative 5. Sorry, you have to say that slower because you cut out.
Negative 5.147, and then the question 18 was 2.214. I'm going to go ahead and save that and submit it again.
I'm gonna submit as well.
Whatever I get doesn't really matter because I can't fix it anyways, but I think that should be correct.
Yeah, that's all correct because I got 19 out of 19.
All right.
Oh,